Okay, this is lesson 4.5 on compound inequalities. So most real life situations do involve compound inequalities. And what do I mean by compound inequalities? I mean a situation that can be represented by more than one inequality. So a lot of times this is the case on the expressway. On the expressway, you're just not allowed to go any speed that you want. So let's say that we have x represents the speed on the highway, an expressway that you can go. Well, a lot of times, like in Michigan here, we know that you have to go less than or equal to 70. But at the same time, we also know that if you only went like 20 miles per hour, that would not be okay either. So oftentimes expressways will have a minimum speed. So they might say that your speed also has to be greater than or equal to 55. This is a compound inequality, and this compound inequality we would actually write, so our speed's in the middle, so our speed has to be greater than or equal to 55, but our speed also has to be less than or equal to 70. This is a compound inequality for an AND statement. A compound inequality for an AND statement. So try quick check 1, which is on page 227. Go ahead and hit pause, and then when you come back, or when you're done, hit play again. Okay, so for this example, it says write a compound inequality that represents each situation, graph your solution. So 1a says all real numbers greater than -2 but less than 9. So the way that I would write that is all real numbers. So you pick a variable, like maybe we'll say n here. So all real numbers that it says are greater than -2, so greater than -2, but also less than 9. And then when we graph that, because it did say to graph it, I can put -2 here. I'll just throw a 0 here and we'll go up to 9. And I'll just say like 5 is in here. Okay, so open circle at -2, open circle at 9. So all numbers greater than -2 but less than 9. So that would look like this. Okay, and then we've got the second one. The books were priced between $3.50 and $6 inclusive. So this is an interesting word, this inclusive word. So that means it includes the price, $3.50 and $6. So inclusive means includes. So we would write again that the books, and I'll just use B for books, were priced between $3.50 and $6 inclusive. So between $3.50 and $6 inclusive. Inclusive means you need the equal to because it includes the prices of $3.50 and $6. So when you go to graph this one, so if I have 0, 1, 2, 3, 4, 5, 6, I want to get up to 7 here. There's 7. So since it includes $3.50, I'd put a closed dot at $3.50 and a closed dot at 6, and everything in between. So all the books are in between $3.50 and $6. Okay, so those are our AND statements. So let's look at just some compound inequalities that we're going to solve. So this is saying that 5 minus f is less than 5 and 5 minus f is greater than 2. So this is an AND compound inequality. So I'm actually just going to pull this apart because it really is two inequalities that I have to solve. So the first inequality I have to solve is 5 is greater than 5 minus f. And the second inequality is 5 minus f is greater than 2. So for my first one, I would just subtract 5 from both sides, and I would get 0 is greater than -f. Now this is really like -1f, so I'm not done because I have to divide by that -1, and that's going to flip the sign. 0 divided by -1 is 0, so I would say f is greater than 0. And then over here, I'm going to subtract 5 from both sides, and I get -f is greater than -3, and again, that's like -1, so you divide by -1, flip the sign, f is less than 3. Now, since this is an AND, I can mush the two of these together, because I know that f has to be greater than 0, but f also has to be less than 3. Oh, you didn't actually see that. There it is. So f had to be greater than 0 and f had to be less than 3. And you always want, when you do write these, because a lot of people say, well, can I put the 3 over here and the 0 here? You always want, put your smallest number first and end with your greater one. So if I put this on a number line, and I had 0, 1, 2, 3, 4, this would be open circles at 0 and 3. And I would shade everything in between because it has to be greater than 0 but less than 3. But it doesn't include 0 and 3. It's not inclusive. So let's look at another example. So again, these are two inequalities smushed together. So I'm going to pull them apart. And I'm going to do -4 is less than r minus 5. And r minus 5 is less than or equal to -1. So over here I'm going to add 5 to both sides. And I get 1 is less than r, or r is greater than 1. Over here I add 5 to both sides, and I get r is less than or equal to 4. So now, and this one is a less than or equal to, now I can smush these just right back together and just have like that. R is greater than 1 and r is less than or equal to 4. And so now when I go to graph this, 0, 1, 2, 3, 4, 5. I'm going to put an open circle at 1 because r is greater than 1, so that's this way, but r has to be less than or equal to 4, so that's a closed circle at 4 because it can include 4. So that's what my solutions would look like on a number line. Okay, so now go ahead and try, I believe it's quick check 2. Which is on page 228. There's 3 of them. Page 228. Hit pause and then play when you're ready. Okay, first one, A is -6 is less than or equal to 3x, which is less than 15. So I'm going to pull this apart, and I have -6 is less than or equal to 3x, and I have 3x is less than 15. So I'm going to divide both sides by 3, and I get x is greater than or equal to -2. I do have a -2 here, but I didn't divide by a negative, so I don't flip the sign. Over here I divide by 3, so x is less than 5. And so now I just am going to squish these back together because the variable is the same. So I have -2 is less than or equal to x, which is less than 5. So we squish them back together when it's the and like that. So I think you were supposed to graph these. Yep. So I would have -3, I'll put 0, 3, and I'm going to go 6 here, so it's going up by 3's. So at -2, we'll say this is -2, you should have a closed circle, and at 5 you're going to have an open circle, because x is greater than or equal to -2, it includes -2, and it does not include 5. It has to be less than 5, so it would be all that stuff right there. Okay, let's go ahead and try B now, which was, we're going to split that apart. So you should have had -3 is less than 2x minus 1, and 2x minus 1 is less than 7. So you add 1 to both sides, and you get -2 is less than 2x. Divide by 2, don't flip here, so x is greater than -1. Over here, add 1, 2x is less than 8, divide by 2, x is less than 4. This is an and one, so I can squish them back together. -1 is less than x, which is less than 4. These are going to be open circles at -1 and 4. 0 here, might as well just put 1, 2, and 3. And x is greater than -1, but it's less than 4. Okay, for C, you should have had, let's see if I have enough room over here that I can do C in here. So you would have had 2 of these to solve are 7 is less than -3n plus 1. And then you also should have had, well, I'll just solve this one first since I don't have a lot of room here. So I subtract 1 here. I get 6 is less than negative 3n. Let me kind of divide this up here. Divide by negative 3. Now this one you do have to flip the sign. So you have n is less than negative 2. So that's the first part. The second part was negative 3n plus 1 is less than or equal to 13. So you subtract 1, you get negative 3n is less than or equal to 12, and you're going to divide by negative 3, so you got to flip the sign. So n is greater than or equal to negative 4. So this is one of those times, here's a solution and here's a solution, where I'm going to put the smallest number first. So I would have negative 4 is less than or equal to n, which is less than negative 2. Oh, and you didn't see that. So again, I just took the smallest number and I did negative 4 is less than or equal to n, which is less than negative 2, because the alligator's in the negative 2 and the n. So when you graph this one at negative 4, you would have a closed circle at negative 2, so negative 3, negative 2, negative 1, 0, you would have an open circle, and is greater than negative 4, but has to be less than negative 2. So it would look like that. Okay, so that was quick check 2. Now, those are all and compound inequalities. Now we're going to talk about some or compound inequalities. So a lot of times you will encounter these at something like the movie theater, because at the movie theater they give discounts on tickets. But a lot of times they give discounts to 2 different types of people. Well, there's more than 2, but one type of person is senior citizens they give discounts to. So they might say if D equals discount, you get a discount, let's say if you're greater than or equal to 65. But sometimes they give discounts if you're less than 5 years old, we'll say. So, or you get a discount when you're less than or equal to 5 years old. So in this case, this is an or compound inequality. There are 2 different inequalities to represent this. And so the way you would graph this, so if I have 0, and I'll go 10, 20, 30, 40, 50, 60, 70, 80. Okay, so you get a discount if you're greater than or equal to 65. So at 65, I'd put a closed circle. If you're any age greater than that, congratulations, you get a discount. And if you're less than or equal to 5, closed circle at 5. If you're less than that, you also get a discount, which you really can't be less than 0. So I should just stop right there. But so that would be a way that we would represent this. This is for an or compound inequality. So go ahead and try quick check 4, which is on page 229. And then hit pause. When you're done, hit play again. Okay, so this one says write an inequality that represents all real numbers that are at most negative 5 or at least 3. So at most negative 5 means that it has to be less than or equal to negative 5. So you would have n is less than or equal to negative 5, or at least 3. So you would say or n has to be, if it's at least 3, that means it might be 3, it could be 4, it could be 5, so n has to be greater than or equal to 3. So on your number line, we would have, so let's say I have negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So n is less than or equal to negative 5. So that's a closed circle because it's equal to at negative 5 and everything less than that. And n is greater than or equal to 3, closed circle at 3, and it's this way. So the way I remember this as an or compound inequality kind of reminds me of like magnets pulling away from each other. That's what it reminds me of, like going in opposite directions. So we're going to go ahead and solve this one. This is 2 inequalities, and unlike and where they were smushed together, these ones are actually separated by the word or. So you remember, see the word or, you're going to have that kind of repelling effect when you look at the number line. So for this first one, I'm going to subtract 2 from both sides, and I get 3x is less than negative 9. I'm going to divide by 3. No flipping signs here because I did not divide by a negative. Is less than negative 3. Or, I'm going to go over and solve this one. So I subtract 5. And I get negative 4x is less than negative 4. Now this one I did divide by a negative. So that kind of warning should be going off in your head. Okay, I got to flip the sign. So x is greater than 1. So this is what I'm going to go ahead and graph then. So I get my number line out, and I'll put negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Okay, so x is less than negative 3. So open circle at negative 3, and I shade everything less than. X is greater than 1. So this is an open circle at 1 and everything greater than. So you can kind of see again that repelling. Now, if you wanted to check, you could pick a number in either solution, like any set of numbers, to go ahead and check here to see that you are right. Okay, so go ahead and try. Oh, no, we're doing another one together before you try one. Here's another one. Wait, is that the one we just did? Never mind, that's the one we just did, so we're not doing that one. So yeah, now it's your turn to try. Quick check 5, where are we at? Which is at the bottom, or kind of middle of page 229. So hit pause and play when you're ready. Okay, so this one was negative 2x plus 7 is greater than 3, or 3x minus 4 is greater than or equal to 5. So over here I'm going to subtract 7 from both sides. And I get negative 2x is greater than negative 4. Now I'm going to divide by negative 2, so that means I need to flip the sign. So this becomes x is less than 2. Or over here I'm going to add 4 to both sides. I get 3x is greater than or equal to 9 divided by 3. So no flipping there, x is greater than or equal to 3. So on my number line, these are relatively close to each other. So I have 0, 1, 2, 3, 4, 5. So x is less than 2. Open circle at 2, everything less than 2. X is greater than or equal to 3, everything greater than 3. Okay, so that's it. That's what you should have had. Go back and watch any parts that you're not sure of. And that's it. Thanks for watching.